Hi, this is Arif Khan with Cadence Design Systems. We're here to show you our latest PCI 6.0 subsystem IP. This particular IP on our test chip is built in 5 nanometer. It has our PCI 6.0 controller, which is also capable of supporting CXL. This test chip is hooked up to a Keysight exerciser system. The Keysight is connected as a root port, and our test chip is connected as an endpoint. Our subsystem is fully capable of supporting both root port and endpoint modes. The value of building this subsystem is that our customers like to see the full protocol stack tested in its entirety in 8-lane configurations, because this de-risks the IP as a subsystem so that they can actually integrate these designs and save their integration time and cost of development. I'd like to call on Mark Luenas, our VP of R&D responsible for this IP, to talk a little bit more in detail about the design of this IP and how we've met the performance specifications.
Hi there, my name is Mark Luenas, and I'm the Vice President of R&D for the PCIe PHY team at the Cadence Design Systems Intellectual Property Group. And today I'm going to show a demonstration of our PCIe 6 test chip with a PHY and a controller interoperating with the Keysight protocol analyzer. So what we have here is our test chip that has an 8-lane PCIe Gen 6 PHY with an 8-lane PCIe Gen 6 controller. I'm talking to a protocol analyzer from Keysight. So this is a protocol exerciser also. It produces traffic flowing between these two parts. So the PHY and the PHY test chip is quite a complex beast. I mean, it's got an 8-lane PHY and an 8-lane controller, so we can show the full protocol stack. Up here on the screen, you can see that we're up in PCIe Gen 6, but you can see 64 gigabits per second with 8 lanes, and the link is stable with no errors. And you can also see down here the histogram for one of the receivers on one of the lanes, showing that the bit error rate is far lower than 10 to the minus 6. Other things to point out are the test chip shows that the PHY and the controller can be integrated together, and that all the digital interactions with the analog circuits are well controlled, and noise is suppressed, so that we can get stable, good performance, even in the full SoC environment. We feel that what we have here is an industry first, in that we have a multi-lane controller and PHY integrated in a true SoC environment, which de-risks the entire subsystem for our customers. I'm going to show a demonstration of our PCIe Gen 6 PHY, which we have on a test chip with our controller, interfacing with the latest Anritsu bert, showing 64 gigabit per second traffic for PCIe Gen 6. Okay, and here we have our device under test, which is our test chip with a PHY. It's an 8-lane PHY and an 8-lane controller. Now we have all of the lanes active, but we're only testing one lane at a time with the bert. And so we have data coming from the bert at 64 gigabits per second in PAM4, that's fed through a 30 plus dB channel, shown in green. All this green stuff is the channel, and that's fed through this cable into the receiver on one of the lanes. The signal's recovered and equalized by the DSP in the receiver, and then the parallel data is fed into the transmitter on the same lane, and then fed out into the bert where it's checked. So this bert can be used is used to inject all the impairments that are required for the PCIe Gen 6 JTOL tests, and that's done here. And you can see that the bit error rate is shown. The other important thing to note about the bert is that it is protocol aware, and that the negotiation of the bit rates from Gen 1 to Gen 6 is done using the bert. You can see up here that we had to do equalization for PCIe Gen 3, 4, 5, and 6. And this shows that the controller that's implemented on the test chip is interoperating successfully with the LTSSM that's implemented on the bert. And so this is the main method of testing the receiver for its overall performance for PCIe Gen 6. Thank you very much for your time. For more information, visit cadence.com.